So we are working on some numerical variables, and those numerical variables are going to get applied in some mathematical calculations, and due to that we got some betas, and from there, from those betas we are doing some kind of diagnostics. So whenever we are doing diagnostics, we use those numerical variables to create some metrics, and from those metrics, for example, adjusted R square, VIF, there are many metrics that we try to use. Okay, even in model adequacy we try to plot the data in residual plots. Based on those residual plots we are trying to infer something. So every time we are doing this, we are using all numerical variables. We have never used any categorical variables. Now the discussion topic today is dummy variables, which is nothing but, this is also called one hot encoding. So these dummy variables will be helpful whenever you have any categorical variables in your model or in your data, and you want to include those categorical variables and then use it as a regression variable. Now how to use this is the question. So dummy variables technique to include categorical variables in the model. So when we start including categorical variables in the model, we have to use this technique to convert the variables, the categorical variables, into something called dummy variables. Now, how to use these dummy variables? If n is number of levels of a categorical variable, then use n minus 1 dummy variables. Now what is this levels of a categorical variable? We'll see with an example now. So for example, gender. So gender, the column will have generally male or female. So for this we can call the gender as a categorical variable. It is having two levels. Two levels means each value that the categorical variable can have can be taken as a level. So for example, here male is one level, female is another level. So that's how we can interpret these things. So one second. Okay. So similarly, let me give you another example where you can find out the levels yourself. Let's say the column name is religion, and it holds only Hindu, Muslim, and Christian. So how many levels you can say? So this is having 3 levels. So those are the levels. I mean, levels are nothing but the number of distinct values that the column can take. It could be Hindu, Muslim, or Christian. That is the only 3 options that you have that you can choose from. for every variable. I mean, for the variable of religion, for every observation. So now, if there are three levels like this, Hindu, Muslim, Christian, then I can encode this into two dummy variables. That's what I said about this statement. If n is the number of levels of a categorical variable, then n minus 1 is the number of dummy variables you can create. You can also create, if n is the number of levels, you can also create n dummy variables, but in that case, it's not really that much useful. So you can discard one variable. That is the easiest way. So that, I mean, that is the minimum number of dummy variables that you can create. Let's see how to create the dummy variables. Let's say the data is name and religion. Let's say name is Robert and he is a Christian, and another name is Javed and he is a Muslim, and let's say the third one is Sandeep himself, who is me, who is a Hindu, and it could be any other data as well. But if you have this kind of data, the problem is, how would I use this value called religion in the model? Because my model is always saying beta equal to x transpose x inverse into x transpose y, where all the x values, only if it is numerical values, this multiplication, this inverse, the transpose, everything will make sense only if the values are numeric. If the values are not numeric, then how would I do x transpose into x? I am multiplying something. I cannot multiply these kind of Christian into Muslim or Muslim into Hindu or something like that. There is no way I can do this. So that's the reason why this formula may not be applicable when the data is when you're having some data which is categorical. Okay, now how would we convert this into numeric values? So what we can do is, we can convert this religion categorical variable into two dummy variables. The reason for using two dummy variables is there are three levels. Three levels means three distinct values it can hold. The religion can hold. So what I can do is, I can convert this religion variable into, instead of using religion, I will now use two variables. One is called is Christian, another is called is Muslim. Any two variables, I don't care. Maybe it could be is Hindu is Muslim, or is Muslim is Christian. Any two values you can hold. The third value is automatically inferred. I'll show you how. So again, you'll have Robert. Is Christian is 1 for him. What does it mean by 1 is, 1 always means the true, 0 means false. So he's a Christian but not a Muslim. Similarly, this guy, sorry, Javed, yeah, let me write properly. And this guy is not a Christian, he is a Muslim. And the third guy is neither of them. So you encode this as 0, 0, because he is neither a Christian nor a Muslim. Is it clear how to encode this into some numerical values. I converted something like religion into is Christian and is Muslim. I converted this variable into two different variables, and this encoding is also called one-hot encoding. So if someone says, do you know one-hot encoding? Do not worry, it is nothing but dummy variables. It's just another name for it. Okay, any questions on this? How to convert it into dummy variables?
So if the data lies in, for example, 3 levels, can I create 3 dummy variables or
So if that, how many levels do I have here?
3 levels?
How many I created?
You created 2 variables.
You want to, what if I create 3?
Yeah, that's what I'm asking. Is two is I mean
It's not 2 is mandatory.
okay.
2 is not mandatory. You can go for 3 also. But
Okay.
n minus 1 is the minimum number of variables that you can create.
Yeah.
Okay, instead of creating 3 variables from this, what if I create 3? 3 is also possible. It's not
Yes.
that it is wrong. Some people use this also. I'll just show you. Is Christian, is Muslim, and the final one is Hindu. You can create both, all of them.
Okay.
Now what happens to Robert? 1 0 0. Javed is 0 1 0, and Sandeep is 0 0 1. But the question is, if you have more variables, the number of more levels, the number of variables is increasing. Okay.
Yes, sir.
Actually, the only reason why we go for n minus 1 is it is completely possible to represent 3 levels in two variables. That's what I did here.
Yes.
For Hindu, there is no variable called is Hindu here.
Yes, something.
But what I did, he's not a Christian, he's not a Muslim. That's how I encoded him.
Okay.
Now, if I add one more variable, the only thing is, compared to this will take a little bit more time to process, because what we are doing x transpose x and then inverting that matrix and then multiplying with x transpose. So all these things are dependent on x. So the processing time in the computer will get increased. It may be by little, but it will increase. Okay, that's why we always try to minimize the things. Here we could have excluded the third variable. That's why we excluded it. It's not a wrong thing. It's definitely not wrong thing. You can always go with 3 variables also. But many people, what they suggest is, because it is easier to exclude the third variable, go ahead and exclude it. It's more like less luggage, more comfort. You have less luggage here. In this case, you'll have more comfort. Your processing will be very easy, very fast. Okay.
Yeah, got it, Sandeep.
That's the only reason why. Otherwise, you can use anything. Okay. Now,
Yes, Sandeep.
let's see how it goes in Python. Okay. I'm loading the data set. Imports. I'm still using the stats model formula API. And for any plots, I'm using matplotlib. And NumPy is what I'm using for any mathematical calculations, scientific mathematics. I'm plotting the matplotlib inline, and then I'm loading the data set. So the data set, let me show you the data set. So this is about the smoker and non-smoker. So you can see the data is having smoke yes or no. So sometimes some people smoke, some people may not smoke, and it is encoded as yes or no. Now I need to encode this as a dummy variable because I want to include this smoking habit in the model. Now how to do that is Pandas has a very good support for creating these dummy variables. It is called get dummies. What it does is, let me remove this drop first for now. So what it does is, it creates a dummy variable for each of the level, just like the way Abid told me, asked me. So what it does is, birth, smokers, new. If you see that, actually there are two levels. It is actually creating two dummy variables. This is what you have asked, Abid. You can still go ahead with how many levels you have, those many variables you can create.
Okay.
It's not an issue. But if you don't want and you want lesser number of variables to get created, what you should do is drop first equal to true. What it does is, it will drop one of the variable and create only n minus 1 variables. Now if you run this one, you'll see smoke yes equal to either 1 or 0. There is only two levels. I created only one dummy variable. Is it clear?
Yes, Sandeep.
So the only difference here is, here in this column you can see both 0 and 1, because in one variable I can represent two levels. But if I remove this, you can see here smoke no is 0, smoke yes is 1. It is redundant actually. When I say smoke no equal to 0, it means that he is smoking. Is it clear or not? Does he smoke or not? If that is the question, if my question is does he smoke or not, smoke no, if it is false, it does mean that he is smoking. Smoke no, if it is no, or if it is true, when I say 1 for smoke no, what does it mean? He doesn't smoke. If I say he doesn't smoke here, it is a redundant information if I say yes here. Okay. Now the problem with this approach is, there will be high correlation between this variable and this variable, and that will lead to some multicollinearity. Okay, let me show you. I have never shown this, but let me try to show it to you. One second. I think I should use this one. Yeah. You can see there is a high correlation. Very, very high correlation, and it is a negative correlation. Because when this is 1, this will become 0. When this is 0, this is 1. It is exactly reverse. The first, this smoke underscore no column is exact exact reverse of the smoke underscore s column. That's why you're getting a negative correlation. Even then, it is a 1. It is a perfect 1 correlation, which means there is a perfect strong negative correlation. These problems will happen if you use this kind of two variables, two dummy variables. Is it clear, Abid?
Yes, Sandeep.
So these kind of problems will come. Now, if you see the VIF, let me go with the VIF. Let's see how it goes. I don't know where I kept it. Multicollinearity. Let me copy the VIF code. I think I should convert it into np dot array of this one. Now, what is the x variable? I don't want this one. This one, I want only last two. This is the last two. Let me give it to VIF. One second, there is some problem with here. Yeah, you can see here. How much is the VIF? 146, 154. First one is okay. The remaining two VIFs are very bad. VIF you will get for every variable. So I created all the x variables into some matrix and gave it to the VIF function. And I got very high VIF. Actually, VIF greater than 10 is bad, but I got 146. But if I do the same thing without those dropping the first variables, I mean, after dropping the first variables, then I may not get the same VIF as much as I get here. Let me remove the correlation coefficient. It doesn't make any sense now. See, it is only 2. VIF when it is one between 1 and 5, it is okay. VIF close to 1 is perfect. So it is not a perfect. It's not having a perfect multicollinearity problem. Sorry, if it is not a perfect situation where there is no multicollinearity, but still it's not a much multicollinearity. Are you clear, Abid, to your question?
Yes, Sandeep, I got it, Sandeep.
So the moment you create more dummy variables, there will be relations between them, like the way I showed you.
Yes, Sandeep.
That's why it's always good to avoid these things. Okay, now what am I trying to do is, so this is the gestation period, and this is whether that person smokes or not, and this is the weight that you are going to get finally. So what I'm going to do is, I'm doing a scatter plot. So this is how actually the data looks like. You can see actually from the data itself, now you can try to spot if the data is having any problems like variance problem, I mean the homoscedasticity problem or whatever. if you draw straight lines like this at the edges of the data, you can see the distance from here to here and here to here and here to here. The variance never changed. The variance is always the same. So using the data plot itself, the plot and the scatter plot of the data itself, you can see here the variance is not changing. So there is no homoscedasticity problem. I have not even given you the residual plots. What I am saying is only using the scatter plot of the data without even plotting the residual plots, you can analyze and say that there is not much variation in the system or not much homoscedasticity problem in the system. But this you can only do when there are only one x variable. If there is only one x variable, you can do a scatter plot. If there are two x variables, then scatter plot doesn't make any sense. Always remember that. Here, because I have only one variable, I am using the scatter plot. Now let's see. I'm creating a formula where this side it is weight and gestation and smoker or not smoker. Let's see the model summary. It's saying 89%, 89.6% R square and 88% of adjusted R square, which is okay. It's not a bad model at all using the R square value. Now you can see the residual plots again. How to see the residual plots? Use the y minus y hat. Y minus y hat is my E. Y hat is nothing but model dot fitted values. So if you plot y hat with E, you can see the data is also looking very good. How do I say that? Draw a line like this. You can see the distance from each point to this line above the line is always same as the distance from the below. This is also same. There is a little problem here, but it can be ignored. Not much actually. It's not much. Okay. Any questions on the residual plot? Just look at it. You can always ignore some of these points. For example, I feel that these points are too much outliers. I'll remove this. Now you can see from here to here, almost everywhere the distance is same, which means the variation is almost same except for these 3 points. That's why I say the variance is, there is a homoscedasticity. The data is homoscedastic. Is it clear? Residual plots, I think by now you should be able to interpret. We have seen a couple of things, couple of residual plots. Okay, are you able to interpret right now? Vidya?
No, makes sense.
Yeah, okay. Like I said, initially the first time when you see it will be problematic. Again, you can also see this entire data. If you think of this entire data as a band, okay, this band actually is parallel to the x-axis. Like I said, the band should be either parallel to the x-axis like this, or it should be parallel to the y-axis like this. It should not be like this. If it is like this, then there is some problem. So in this case, it is not like this. It is a parallel one to the x-axis. So I don't have any problem with the residual plot. If it is like this, I have to do some transformations. If it is cutting at an angle, if this band is cutting at an angle like this, it is a problem. You have to do some transformations. Now that is not the problem that I am seeing. So that is how actually you can look at the data. By the way, this data is for women. Their gestation period, this is 38 weeks, 36 weeks and all. And whether she's a smoker or not. And then finally the weight of the baby that that is born after, finally. So you can see it is 42 weeks of gestation period. Weight is 3.3 kgs, something like that. And she is a smoker, all these things. Okay. That is about the dummy variables. Any questions on the dummy variables, how to make? I think this should be very, very simple. Only one point I should make is, I gave you one example where I gave you names. Now, how many levels of names you have here? Actually, as many data points you have, as many observations you have, those many names you'll have. Mostly names will be distinct. Or similarly, if there is something called ID, let me call it as, let's say, employee ID. Now, employee ID is mostly unique. For example, E101, E102, E103. As many data points you have, those many employee IDs you'll have. Now, if you consider this as a categorical variable, because anyway this is not a numerical variable, for this employee ID, you will have to create, if there are n data points, n minus 1 dummy variables. But the point is, if all of them are unique, if all the values are unique and there is no repetition, there is no point in keeping this employee ID in the model. So remove this from the model. Always remember this part. Are you clear? There is no point in keeping this because this employee ID is not, it is a unique value. It is unique only to this person. Similarly, name is also unique for every record, every observation or every row. For this row, you got Robert. For another row, you got Javed. You'll not see repetitions mostly. Sometimes you may see, but it is very rare. So in those cases, if the levels are too many, maximum I would say go for 10 levels. Anything more than 10 levels, again this is some heuristic I'm giving. You can also go for 15 levels if you want, but the point is, do not go for hundreds of levels, because if there are 100 levels, you have to create 100 dummy variables, 99 dummy variables. That will fit you for nothing actually. It will give you nothing actually. So only give the use the dummy variable technique only when the number of levels is low, maybe less than 10 or less than 15. After that, if there are let's say, if the sample size is 1000 and you got, let's say, 900 dummy variables, 900 levels for a categorical variable, then don't go for it. Don't go for dummy variables. Then the question is what to do with it. Just discard that variable. Do not use it anymore. Okay. Any questions on this? Dummy variables?
Awesome.
Okay. So that's all I have for dummy variables. But I have included something called press. There is some statistic called press. I'll talk about it after the break. Let's take a break of 5 minutes, or shall we take 10 minutes? Because we'll have time today, maybe 10 minutes. We'll have time today. Let's take a break of 10 minutes. We'll come back at 7:20. We'll complete the press statistic and see how press is influencing the, I mean, how can you use the press for analyzing the uh, regression model. So before we go for a break, I'll just ask you one question. Are you clear with the regression topic, the entire regression topic, or what is the purpose? What are the analysis that we have done? Are you clear with all those things? Vidya, are you there?
Yes.
Yeah, conceptually, yes. I think when if you give us another project, when we practically do it, I think then we might understand better or even have some more questions maybe.
Sure, sure. We will get to the project. The only thing is, we have did many analysis, but in the project, not all the projects are made same. Some some projects need transformations. Some projects may not need transformations. Okay, or some projects need something else. So the analysis, it doesn't mean that you have to use or apply all the techniques that I have discussed today or until today. So I'll try to give you some problem where you can try to use maximum number of techniques, but at the same time some techniques you may not be, I mean, it may not be useful to use. So that is okay, I believe. So for example, in this case, you can see residual plot is looking good. Why do you need a transformation here? You don't need. So these kind of things will be there. So there will not be any data set where all the techniques in the world you can use. That is not possible. Okay, but I'll give you some project where you will try to use maximum number of techniques. Okay, but Vijay, did you get all these techniques in your course also?
I'm sorry, you got cut off. What did you say?
I'm just asking you, did you cover these techniques in your course? You did some course on statistics and regression, right?
Yeah, I did the dummy variables, but what you taught us yesterday about those the block,
Transformations, the
yeah,
Tukey ladder.
yeah, those things like I didn't learn before, so that was
Okay,
something that was new to me.
okay. Okay. Abid, what about you? Did you get all the concepts clear?
Yes, Sandeep, I am clear until now.
Okay. Okay, let's go to a break and we'll come back at 7:25. We'll take a 10-minute break.
Oops.
Hi everyone, is everyone back?
Yes, I'm there.
Yeah, yes, Sandeep.
Okay, so one thing we still have to complete is the press statistic. So let's see what is the need for this press statistic. Let me add one more page here. So what is the reason for this, first of all? So press statistic is nothing but it is similar to R square or adjusted R square, both of them. It is very similar to that. But the question is, why do we need it? To understand that, let's go back to our burst smokers data set and see why R square is not a good metric here. So the R square that we calculated here, it is based on the data set itself. So what I mean by based on the data set is, let's say, let me write it here, weight, gestation, smoke underscore, yes, this is the data set we have. So in this data set, if you see carefully, if you carefully observe, so this is our y, this is our x1, this is our x2. So this is having some data. Let me write some data here. 2940 is the weight, 38 weeks, and smoker yes. 3130 380 3130 380. Let me take another one. 2420 36 1. So this is the kind of data set that we have. Now what we did is we did something like weight equal to beta naught plus beta 1 into gestation plus beta 2 into smoke underscore yes. This is what I did. Now after I created this regression model, what I did, I created SS residual, and SS residual is nothing but y minus this is y hat, which is weight hat. Instead of writing it as y, let me write it as weight minus predicted weight. So what I did here is I already know this value. I kept it in the model. What does it mean by kept it in the model? This value is used for the model for predicting something else. So let me show you what I mean. Where is the fitted values? So these y hats, y hat minus y hat dot head. I'm taking only first 5 values, and y dot head, first 5 values of y values, first 5 y values. So when the y value is 2940, which is this one, the predicted value is 2803. So what I did is I subtracted this y from y hat. Okay, sorry, I subtracted these two values, y and y hat, and based on that I got something called E. Now E1 means that it is a first error. The first error is nothing but you take this value minus the first value of this one. Using that I got E1. If you see even the errors, the list of errors, the first error that you will see is the same value 136. Similarly, the second value I am calling it as E2, which is 81, which is nothing but the second value in y minus second value in y hat. This is how I continuously did the differences. But the question is, this observation, the first observation, is already part of the model. Because of that, the error is optimized. What does it mean by error is optimized? We are already trying to minimize the error. If you remember our first set of classes, what we did is we tried to minimize the error. By minimizing the error, only then we try to find out the beta values. So the beta values we got is already minimized for this observation. That's why you are getting a lesser error. Maybe you may get a bigger error, but I did not worry about that. Are you clear what I am saying? The error may be more, but because the first observation is already part of the model, because of that, I am getting lesser error, which is 136. Maybe actually for a new data point, for a data point that is not part of the data set at all, for a new data point, the error may be more. Just because this data point is already part of the model, I got the error less. Are you clear with this discussion or not? What I said? Are you clear with this point? Vidya, Abid, any?
Yes, sir.
So just because the data is, this data point is part of the model, my model is trying to minimize the error. That's what is the purpose of my model. That's how I get the beta values. Because this first observation is part of the model, the error is less. If the model doesn't have this value at all, if you remove this value from the model and then just try to predict, your error may be more. That is the error that you have to take. Why? Because your prediction, which is the y hat, the prediction is always about the data point that is not present in the model. The prediction, what does it mean by prediction? Weather prediction, let's say. You don't know what happens in the future. Because you don't know what happens in the future, you're predicting. Now I need the error for that new point that is not given to the model, not the data point that is already present in the model. And this is very, very important. This point gets repeated till the end of the course. Remember this. If this is not clear, let me know now itself. Otherwise, maybe I'll get angry, because this is very, very important point.
So basically what you're saying is the first y hat value is already there in the data set.
It's not y hat is there in the data set. How is that we are predicting y hat? Y hat we are predicting using gestation period and smoke. These two x values. This is x1, this is x2, right? This x1, what is a corresponding x1 and x2 for this? Let me show you that. But smokers of 1 comma, what is this giving me? Dot I log of 0. Okay, this is the first observation. But what I'm saying is, this first observation is already given to my model. What does it mean by giving to model? My model is always simple, this one. In this values, the x and y already contain this weight, which is y value, this gestation period, which is x1, this is x2. All these values are already seen by the model. The model has seen these three things. Based on the y value, the x1 and x2, all these things, it has already optimized the y hat value. How is the y hat value calculated? Once you get the beta value from these values, you substitute the x1 and x2 values. Based on that, you calculated the y value. Now this beta 1 and beta 2 has already seen these three values. Using these three values, it has already minimized the error. How did I find out the beta values? First of all, how did I get this x transpose x inverse x transpose y? By minimizing the errors, right? Yes or no? I have some x value, I have some data points. How did I find, if you remember my initial classes, I told you that I need some prediction line, and I mean line to some straight line which can predict this kind of a data. How can I find the line? The line equation can be anything. It can be like this, it can be like this, it can be like this. There are infinite lines that are possible. That's what I told you in the beginning, right? Out of these infinite lines, how did I predict the appropriate line? Why did I get only one beta naught, one beta 1 and one beta 2? The reason is because I chose the betas in such a way that the errors are minimum. Errors with what? Errors with the given data set. Now what I am saying is, because with the given data set, I am already minimizing the error. the first data point, whatever I'm talking about, I'm first at this moment I'm talking about only the first data point, which is weight equal to 2940, gestation equal to 38 weeks, smoke equal to yes. With this data point, already my line is having a minimum error. Let's say this is my data point. For this data point to the line, my error is already minimum. I already found out a minimum data point, a minimum a line which minimizes the error. Now already the prediction is minimum, the error is minimum. If I calculate R square equal to 1 minus SS residual by SST, if I calculate R square using this formula, what is SS residual? Sum of squares of all the errors. Now each error is already optimized or minimized. Each of these error from each of these data point is already minimized. What happens? Your R square will be at the maximum level. So your R square is not really capturing the predictive power of the line, regression line. It is only capturing the best possible R square that you can get. Are you clear what I meant by R square is maximum? Your R square is always maximum. Even your adjusted R square is also maximum. The reason is SS residual is nothing but, what is SS residual? Sigma y minus y hat whole square. How did you get y hat? For every y point that is present in the model, we are calculating the predictive value. So for example, what is the predicted value for this point? All the y hats are points on the line, and this line you have chosen such that for all these data points the error is minimum. The combined error of all these points is minimum. That's how we started this regression line. Because this from this point to the line is minimum, the error that you get here, this is y, this is y hat. The error that you get for this point, which is y minus y hat, will be minimum, which means y minus y hat, sigma y minus y hat whole square will also be minimum. If this is minimum, this entire value will be minimum. 1 minus of that value will be maximum, which means you'll get a maximum R square that you can get for this regression line. That's not what I want. What I want is, in future, what is the accuracy of my system? What does it mean? I mean, what do I mean by in future? There is a data point, new data point that is coming like this, that we have not analyzed for minimizing the error. We did not minimize the error for this new data point. This is coming tomorrow. This is the data point that comes in future. This data point is not included in this model, which means this line, the regression line that I drew, this regression line is not minimizing the error from this y point to the line. For this data point, I need the R square. I need R square for these kind of data points, not just for one point, but for these kind of data points. Are you clear with this discussion or not? It's more like press is nothing but press is giving the predictive power of the regression equation for data points not seen by the model. if you have not seen the model, this new data point, how much we are predicting the accuracy, the accuracy of the model for this new data point, for predicting the values of the new data point, is what we are interested in actually. Are you clear with this discussion or not?
Yes, Sandeep.
Abid, are you also clear why predictive power is very important? R square is not really important, or R square is not giving the real picture at least. Okay, fine. So that is about the press. Now, how press calculates this predictive power? So what we do is we use something called deleted residuals. Use deleted residuals. What does it mean by deleted residuals? Let me tell you that point. So let me call y in brackets I as ith observation deleted from the model. And yi hat in brackets, I in brackets, as predicted value when ith observation is deleted from the model. What does it mean is, let's say you have 25 data points. What you do is you calculate yi minus yi hat. What does it mean? You delete the ith observation from the model and predict the ith observation value, the predicted value, the y hat of ith observation, using that new model, which has only 24 data points because you deleted the ith observation. For example, what you do is you delete first observation from the model, which is y1, and predict the first observation y hat using that model, which is y1 minus y1 hat, plus you delete the second observation from the model and then calculate the residual from that model. What does it mean by residual? y2 minus y2 hat, which means you delete the second observation from the model and keep the remaining 24 observations. You have 25, you will have 24 here. It doesn't mean that one is removed here, one is removed only here. You remove one from the model, remaining 24 values. From the remaining 24 values, you create a model. For that model, you predict the y hat. Then y1 minus y1 hat will become the first residual. Again, you remove second variable, second data point, second observation from the model, and then calculate y2 minus y2 hat. This will become second residual. Likewise, you do for all the 25 observations. You remove each one from the model and predict the corresponding y hat. and get the difference, because now this observation is not from the model. For example, for this one, this second observation is not part of the model. Your model is not minimizing the error of y2 minus y2 hat, because second observation is not part of the model when you are calculating this residual. So what you call is this one, y1 minus y1 hat, you call it as e in brackets 1. What does it mean is it is a deleted residual. What does it mean is first observation is deleted from the model and you calculate first observation residual. Second observation is deleted from the residual and you calculate second residual. Likewise, how many models you create? 25 models you create. Each model will have one observation deleted. Then you calculate all these sum of squares of all these residuals. Square of this, square of this, square of this. Okay. This is called press statistic. Are you clear how to calculate the press statistic? Sorry, press residual. This is called press residual. I'm sorry. This is called press residual. Press is nothing but P is for predicted, PR is for predicted, error, sum of squares. This is what is press. So once you get predicted press residual, what you do is you calculate press statistic, which is similar to R square, which is nothing but 1 minus press by SST. Press residual by SST, which is nothing but, if you see, it is nothing but SS residual by SST. Similar to that, only thing is you delete the value from the model and then calculate the residual. Are you clear how press is calculated? Is there any questions?
No questions, Sandeep.
Abid, are you also clear? Okay. Now you can see how many times you have to create the model. You have to create the model as many observations as there are in the data set. If there are 25 data points or 25 observations, it means that you have to create 25 models. Every time you have to remove some observation from the model and then calculate the model. But this is very tedious, because here you are having only 25 data points. Tomorrow, if you are having 1 million data points or 1 million observations, you have to calculate this model for 25 times, 1 million times, if there are 1 million data points or 1 million observations, because every time you have to remove one observation and then calculate the error. Second time again you have to remove one observation, calculate the error. This is very, very tedious. So what statisticians have found is they have found a very easy way of calculating this press residual. I'm not proving this, but press residual EI can be created using the normal residual without any deleted residual by 1 minus HIA. This is a simple formula. HIA is nothing but it is from the hat matrix diagonal value of the hat matrix. Diagonal value of the hat matrix. I have already told you about hat matrix. Hat matrix H is nothing but X into X transpose X inverse X transpose. This is your hat matrix. Hat matrix is always the dimension of the hat matrix is n by n, where n is the number of observations. So if you have 25 observations, your dimension of the hat matrix will be 25 by 25. Now HII, now hat matrix is always a square matrix. You can see H11, H12, H13, so on, H1n. Likewise, you will have H1, sorry, sir, I should use H21, H31, Hn1. And for every row, it will be like this, H12, H13, so on, H1n. You'll have n by n matrix, which means 25 by 25, and the number of observations is 25 in the data set. Now your hat matrix HII is nothing but this diagonal values. All the diagonal values will correspond to HII, which means E1 you calculate from deleted residual for 1 is nothing but E1 by 1 minus H11. If you have to calculate E2, it is nothing but E2 by 1 minus H22. Why am I calculating like this? Because it is tedious to calculate 25 models. It is tedious to calculate 25 models. Instead of calculating 25 models, you calculate only one model, and using that model and using the hat matrix, you can calculate the deleted residuals, which means you have to only calculate one model, and using that model you calculate all the deleted residuals, which is easier. Are you clear how to calculate the EI? Ith deleted residual. Okay, using this generally people will calculate the press residual. Let's see how the press statistic can be calculated using R. In R, actually there is a simple method. Let me push it up. It is called, let me push this also up. I have to rearrange a little. This package is called again outliers influence, and there is something called OLS influence class. You have to import this. Once you import this, give your model to the OLS influence, you get some OLS object. Inside that there is a hat matrix diagonal, which means you will get all these HIIs. All these HIIs you will get. Using those HIIs, if you see, it is a array, which means this is H11, H12, H13, so on and so forth. Using all these HIIs, you can calculate the deleted residual using, I already calculated the E, if you remember, y minus y hat, I already calculated earlier before the break. Using that E by 1 minus HII, you'll get all the deleted residuals. It is as simple as that. You don't have to create so many regression equations. All you have to do is use the hat matrix to calculate the deleted residuals. Then if you do a sum of all the deleted residuals, sum of squares, you will get the press residual. This is your press residual. Or to create the press residual, what you can do is, for this OLS influence itself, you have a variable called ESS press. If you run this, you will get again the press residual the same way. It should be the same value actually. You can see it is exactly the same value. Okay. Once you get the press residual, all you have to do is you have to create a try to find the press statistic. What is the press statistic? It is nothing but 1 minus press residual by SST. So SST I am calculating. Y is nothing but the weight of the baby. Y bar is the average weight. Sigma y minus y bar whole square, which means sum of all the y minus y bar whole squares will become my SST. Using the press residual and SST, now I can calculate the press statistic, which is 87.5%. If you see, I told you that R square will always be more than the press residual. Let's see if it is true or not. You can see R square is 89%, but actually my real predictive power is only 87.5%. So to summarize, to use the press residual or to use the press statistic, the real use of the press statistic is reporting the final accuracy of the model. So do not say my accuracy of the model is 89.6%, which is wrong. 89% of the 89% is only for the given data set. For the new data set, the data that you never saw, for those kind of data, 89% is a wrong metric. If you have to say what is your accuracy of your model, your regression model, you have to give your press statistic, because this is for the model where the data points are not included. This is the accuracy for which the data points for the future data points. This is the accuracy for the future data points of the model. That is 87.5%. Is it clear so far? What is press and how to do it in our Python?
Yes, Sandeep.
Okay. Any questions? Any questions on press or dummy variables or anything that we covered in regression?
I'm still looking at yesterday's. Maybe I might have a question or two tomorrow or next week about yesterday's class and today's class. But for the most part, I understood. I guess it just takes a little bit of a habit to get into this thinking.
Yes, that is the more of it. In fact, this is called, this is a technique called leave one out cross validation. So the real reason why we did all these press statistic is because, I mean, this technique is called leave one out cross validation. That is only for your memory. But the real reason why we did all this press statistic, delete one observation and then find out the predicted value for that observation. Why did I do all these things? It is very simple. For example, I have given you many Python scripts for your reference, right? There are many Python scripts I am sharing you, and there will be many other Python scripts I will be sharing again in future as well. Now, if I test you on one of the data set, I have shown you some few data sets, at least 4 or 5 data sets I have shown you in regression, in ANOVA. Combinedly, I have shown at least 5 to 6 at least till now. if I test you on a data set that already you have seen, I'm sure you'll be able to solve the problem very easily. But if I gave you some problem or some data set that you never have seen, but I have trained you for regression. Okay, I trained you for solving the problems on regression, but I gave you some problem which you have never seen. Then your I have gave you some problem and gave you some 10 questions on that. Question number 1, question number 2, question number 3, so on. I gave you 10 questions. If that is a new data set, you may answer only 60%. But if it is something that I have already shown you, you may get a better score. Maybe 80% you may be able to answer. 80% of the questions I gave you, you may be answering. Which means you are already trained for the data set that you already saw. But that is not what I am interested in. What I am interested in is, I am interested in something that you have never seen. That is the reason why I am doing all these press statistics. If you see, E1 is the error when the model did not see the first observation. E2 is the error when the model did not see the second observation. So on and so forth. How many such errors I got? 25 errors. How did I get 25 errors? Because there are 25 data points. I remove one data point at a time, create a model, and then try to find the errors. Is it clear now? Just giving you a different perspective or different kind of an example. Are you clear, Vijay, now?
Yes, Sandeep.
So it always makes sense for me to test with a new data set. Similarly, if it always makes sense for me to test the regression with a data point that the regression never saw. So that's why I'm creating 25 regression models. Each regression model will not see one data point. For that one data point, I'm creating the residual. And obviously, that press statistic will be having an accuracy a little lesser than the R square value, because R square saw all the values. This press did not see all the values. One value we are always suppressing. Does it make sense now?
Yes, Sandeep.
Okay. So that's all I have for today. We'll catch up on Monday. One more thing, one more important announcement is Monday we might not have the class. I'll notify you beforehand before the class. Most probably will not have. Okay, 90% chance that we don't have class.
When I mean, should I email you the project or when are we going to?
Yeah, you should email the project.
Okay then.
Okay.
I'll do it. Okay.
You should email me the project. Just send me your Python notebook.
Okay.
And I hope you are only doing it for train.csv, not the test.csv, right?
Yeah, the train one.
Okay, cool. Just email me the project before the class time.
Okay.
The deadline is same. No problem with the deadline.
Okay.
Okay. So that's all I have for today. We'll catch up on maybe Tuesday. I'll send a message before canceling the class, an official confirmation. Okay. So we still have one more topic left over in regression, but we are almost closing. After this, we'll go with the machine learning. So, okay then, that's all I have for today. Bye.